Hello everyone, so this we will be doing today a numerical analysis of flow around the rectangular cylinder. So the main purpose of this paper is basically the validated result that they have mentioned here, which is 2.65. So our main target in this video is to achieve this graph and to achieve the level of CD value of 2.65 at the given dimension, which is mentioned as b by h is equal to 0.6. So with this dimension of 0.6 ratio at the Reynolds number of 800, we should be able to achieve CD max as 2.65 and this graph. So that we will be replicating in our Ansys Fluent, so which will help us to get the other validated result for the different dimensions. As we have to do our CD validation for the rectangular cylinder, so this is the one in which we are going to take 800 Reynolds number. So to get the U, so as we are seeing the graph that it is 2.65 already mentioned here, and the B by H ratio will be 0.6. So based upon that, we put our formula here based upon the density and the dynamic viscosity already mentioned for the air. So we take the Reynolds number 800 and then we substitute it here. So first we already know the formula, and then we take the UH value and then we substitute all the values which are mentioned in this. So based upon that, you get the UH value as 0.0117. So as we have already mentioned the H value to be 20 mm for our dimension, so mentioning here the 20 mm and then going in this tab, we get the 0.584 meter per second. So that is basically our input for the inlet velocity. So the structure for the geometrical structure which we will be making will be looking like this, with the B and H as 12 mm and 20 mm. And this is the geometry of the mesh. So we will be dividing into 8 parts, and the area, reference area, which we will be putting is the multiplication of length and the breadth. So with this 8 position, we will be dividing it so as to get our mesh result better and for our accurate results. First we will make the geometry. So first select the geometry part. Okay, so where is it? Okay, so now we get the geometry. Now click on it. Now right click on it. Let the portal be opened. So now as we see, now we will go with the XY plane. So now zoom it a little bit. Now go for the sketching part. So first we will be taking the rectangle and we will first be making the outside rectangular body part of it. So now we give the dimensions. So first we give the horizontal dimensions one and then this one. Similarly we will be giving for the vertical dimensions also. So this one we will be giving it as 0.07 meter and this one will be 0.27 meter. So for our contours to be watched. Alright, 0.27 meter we have gotten. Now for the vertical one, same we give the dimensions again. X-axis we have to click it up. So V3 we get, again we do it. So V4 we will be getting. So now V3 and V4 dimension we give it as 0.08 meter. Similarly again it will be 0.08 meter. So now seems good. So this one we have done. Now we will be going with the inside rectangular part. So we draw it. Okay, so now again we dimensions we give. Wait, first horizontal we will be giving H6 and again H7. Again we give the vertical one. Okay, now again we give it V8 and VA9. So now we give the dimensions it as 0.08. No, it won't be that. 0.01. Similarly, again we give it as 0.01. Now for the vertical one, V8 and V9, we have already given. So now we give for H6 and H7, 0.006. Similarly for 7. Okay, so now it seems to be completed. So now we give it for the sketching part. Sketch 1 is done. Now we will be creating the surface in it. So we select it, apply, and then generate. So we have created this surface of this geometrical section, but now we have to create the split in it. So to create a split in it, we will be needing to sketch again. So we will select the sketch 2, okay. Now selecting the sketch 2, we will be making the lines for the segregation into 8 different parts as we have discussed in our earlier section. So now, okay, now we have to select this thing, join it above. So now repeat this procedure again. So now we have to do it again. Alright, so now we have to join it up. So you better watch out that the line which you are joining should be connected well with the dots, so as you don't feel any problem while meshing it. So that is the thing. So it's a bit repetitive process, you can skip it a bit. Alright, so let's go ahead. So now it seems to be completed. So last one is remaining. So like this, we have to join it up. Similarly for the below one also we'll join it up. Okay, alright, we have joined it up successfully. So now as we go, alright, we do it for this face split we have to do. So now we select the surface and then click on apply and then select the geometry which you want to split. So now we have selected the geometry. Okay, now we select the body points 1 2 3 4. Okay, so now we have done. Click on apply and then click on the generate. So now we have created a separate part. Again same procedure we have to repeat. Again go to the concept, again go to the tools, face split, select the whole surface and then click on the points 1 2 3 4. Alright, so we have created 2 different portions. Okay, so now again we have to select the upper part. Alright, go to the tools again and then select the face split. Alright, now we have done apply and then again click on the 4 points 1 2 3 4. Alright, so click on apply, we have done it. Now click on generate. 1. Okay, apply 1 2 3 and 4. Apply. Okay, so that's how we have done. So we can select all this differently, which means it's a good one. So now let's go for the meshing part of this thing. So first, alright, we will be selecting the meshing from here. Where is it? Okay, so we got the mesh. So now implement it here and then click on it, right click on it. Alright, okay, now click on the Z axis first. Now we have got these things already here. So now we have the mesh, generate mesh. So it is there, but the big chunks are there, so we need to make it uniform. So select the face meshing. Now do it for all the surfaces. So now we have completed each one. So now generating, we can see that the mesh which we will be getting is uniform, but since it's a still big chunk size, we need to make it small. So the first thing we will do is sizing. So with the selection of all these edges, we will be giving the different sizing, but it should be symmetric. So let's get started. First we will be doing the vertical sizing and then we will go with the horizontal one. Okay, so number of divisions 100. Alright, similarly we will go with the sizing, number of divisions, this one will be 500, since it is the middle section of it from which the air will be there. So for the important CD calculation, it should be precise, so we will make it fine grain size, number of divisions again, and then again we will get the 100 one. Alright, similarly we have to repeat this process. So now we will create the name selection of it. Okay, so now we select the first internal edges and we will give it the name as inlet 1 2 3. Okay, create the name selection, name it as inlet. So now this is done. Now we will select the walls of the rectangular cylinder, name it as rectangle. Okay, now we will select the outer edges, we will name it as wall. Okay, and now similarly we will get the outlets part. Okay, so this will be our outlet. Okay, now it's completed. So we can see we have created all the name selections perfectly. Now we will close it up and we'll go for the meshing part. Not meshing, sorry. Ansys Fluent part we will be going. Closing it up. Alright, so now we will select the Fluent body. So where is the Fluent? Okay, so now transfer it to the setup